Hey YouTube, so this problem here is problem number 94 from chapter 4 from the section on superposition. So superposition just says that if you're looking for a particular current or voltage, in this problem we're looking for a current through a 1 ohm resistor, then that current will be the sum of the individual effects of each individual independent power source. So let's consider this circuit. We have 3 power sources, a 6 amp independent current source, a 10 amp independent current source, and a 75 volt independent voltage sources. So we're going to find the current caused by each of those power sources individually and add them together to find what that I naught is. Now, to do that, we're going to disable current sources by opening them, and we're going to disable voltage sources by shorting them. So let's go ahead and start. So superposition says that I naught will be the sum of the current caused by the 6 amps, so I 6 amp, plus the current caused by the 10 amps, so I 10 amps, plus the current caused individually by the 75 voltage source. So we're going to I 75. It's going to be the sum of those individual effects. So let's first consider the 6 amp by opening the 10. I'm going to open that up. And by shorting the 75. So now we have a circuit that only has the 6 amp in effect. So we got 20 here, and then we got these 3 here. 60 is in parallel with 5 is in parallel with 30. And when you do that, you should come up with that, the equivalent resistance of 4. So let's go ahead and replace all that with 4. So all of this is really 4 amps. And we're looking for this I6. So now we have a current divider circuit. We're going to use current division to find I6. So current division says that the current is going to split like this. Some Req over the branch that you're interested in. In this case, I'm interested in this branch here, and it has a value of 5 ohms, so 5, right? So that's what I'm looking for. So what's my Req? My Req is going to be 20 in parallel with 5, and that is going to be 4. So my Req is 4 over the branch that I'm interested in, so that's going to be the 1 plus 4, which is 5, and then times the total current. So that's how the current will split. And that gives me I6 amps is 4.8. So this is 4.8. So I'm going to erase that and put 4.8 here. Okay. So that is the effect of just the 6 amp. Now we're going to restore the circuit and consider just the 10 amp. So disable the 6 amp, gives me 20 here, and I'm looking for I10 this time, I10, right? I'm going to restore the 10, so we got 10 here, like that. And then we have 60, and then we had 5, and we're going to short out the voltage, and we got 30 here. Again, this is really 4. That's really 4. Okay. So we're going to use current division again. So current division said this is going to split a little piece here and a little piece there. We'll go that way. And it will split like this. A total of 10 amps will split some equivalent Req over the branch that you're interested in. The branch that I'm interested in is this branch right here. So that's going to be 20 plus 1. 21. Okay? Now notice, how do you know if this is a negative 10 amps or a positive 10 amps? The way the current splits is in this direction, the same direction as indicated by the schematic. So that means that it's flowing in the same direction, it must be a positive. So if it was flowing in the opposite direction, then it would be a negative. Okay, so REQ. REQ then is 21 in parallel with 4. And you see. And that works out to be 3.36. So you replace this with 3.36. 3.36 over 21 times 10 should give you 1.8 amps. So I-10 is 1.8 amps. All right, the last piece is to consider just the voltage. So now, again, we restore this, we open up the current sources and leave the 10 intact. So, here's my original. So we open the 6 amp, that means our circuit starts here with 20. And then we got the 1 here, we're looking for I-75. We open the 10, and then we have 60, and we have 5, and then now we're looking at the 75, and then we got 30. All right, so 60 and 30 are in parallel, so I'm just going to combine that together. So 60 and 30 are parallel connected. So what does that give me? So that's going to give me 20. So I'm going to replace this here with 20. Okay. So now you can use a variety of things. What I ended up using was I used current node voltage, or KCL. So I have some Vx here, right, that I want to find. So then I did KCL to find Vx. So Vx over 21 gives me that current away, plus Vx over 20 plus Vx minus 75 over 5 is equal to 0. So then Vx, 1 over 21 plus 1 over 20 plus 1 over 5 is equal to positive 75 over 5. So when you do that math, you should come up with Vx is equal to 50.4, right? So that's his voltage here, 50.4. I'm looking for I-75. The schematic is telling me that I-75 is going into the node, which means the current is negative. So then I-75, since it's going into the node, that's going to be negative 50.4 over 21. So we go negative 50.4 divided by 21 is negative 2.4. So this here is this was 0.8. This was 1.6. 1.6 and then minus 2.4. So then you go 4.8 plus 1.6 minus 2.4, and I naught is equal to 4 amps. And that's the answer to this problem. So make sure to give the Facebook page a like and to share the video on your Facebook page if you got free help today. Thanks.